All right, so on this section, we are not really going to be learning a whole lot of new stuff as far as I'm not throwing in new types of graphs or new types of equations. We're going to kind of stick to our linear equations, which would be when you just had like an x involved. There's not going to be like x squareds or anything like that in this section. But we're applying using those linear equations to actually solve problems. So we're taking these ideas that we've been working with the equations that we've been solving in that, but we're going to have some context provided. So there's going to be some story problems in this section. So we're going to kind of go through them and practice how you would maybe solve them. And we're going to do that by just using linear equations. When you guys are solving an equation on your own, especially if you're doing like a story problem like this, I know a lot of times when students look at a word problem, they're automatically just like they don't want to do it because it's a lot of reading and there's a lot of words and I don't know how to find the information that I need and how to set it up, okay? So what I would suggest that you do is when you're reading through a problem, start to underline things that you think might be important or things that they're giving you information about, and then try to figure out what you don't know. And then be able to try to find a way to, how do I solve for that missing piece? How do I connect the things that they're giving me? Okay. So I would also start out by like writing down, what do you not understand in a word problem? So what do you not understand? If you don't understand what a word means, maybe look it up in your notes. If we've talked about it recently, it might be like the definition might be in your notes somewhere. Ask me or ask someone else in the room if they know what that word means. If you're not with somebody or you're not with me in the classroom, you can always Google what something means if you're confused about what they're talking about. But figure out what you don't know. Then figure out what you do know. Okay, what do you know about the problem? What information are they providing you with? Are there numbers that are being used, money amounts or things like that that maybe we actually need to use to help us solve our problem? And then create a plan or a strategy to solve the problem. We also need to make sure that we're maybe identifying our variables. So where does the x go in the problem? If you kind of follow those couple of steps, you'll probably be able to work your way through pretty much any story problem that you encounter. Okay, so we're going to do some together to practice here. So this first one says the median starting salary. Let's just stop there for a second. Median, we talked about that at the beginning of the year in that chapter that we started out with that had a lot of like stats and probability in it. Median was like the number that was in the middle when I arranged all my data from least to greatest. It's whatever number was right in the middle. So they're talking about median starting salaries. We're talking about money here. It says of a computer science major exceeds that of an education major by 21,000. So exceeds would mean it goes over or like above. Then it goes on to say the median starting salary of an economics major exceeds that of an education major by 14,000. So it looks like right now, just on those first couple of sentences, we're talking about three majors: computer science, economics, and education. Then it says combined, their median starting salaries are $140,000. Determine the starting salaries of the ed major, computer science major, and the economics major. So let's write out some things that we know here. And I'm going to abbreviate a couple of things. So I'm going to abbreviate computer science with CS. And then I have economics, so I'm going to abbreviate that with E. And then I'm going to do ED for education. Hey, Jackson.
Hello.
Thanks. Okay. They don't tell me anything about the starting salary for an education major. They just talk about how much the computer science one is exceeding it and the economics one. So I'm just going to call the education one X because I don't know anything about it. Okay, but now going back up, it says that a computer science major exceeds by 21,000. So that's more. So I'm going to write X plus 21,000. How would we write that for the economics major? What do they say the economics major does? Yeah, X plus 14,000 because it exceeds the education major by $14,000. Okay. The other thing that they tell me is that the combined salaries, so like the total, is this 140,000. So I'm just going to write that down underneath it here. Total is 140,000. What I'm trying to solve for is how much does like each major earn as like its median salary. So to do this, I need to figure out what X is, because once I know how much like the education majors are making, then I'm just going to add those other amounts to it to figure out what computer science and economics gets. So I'm going to add these up, these three. I'm going to add them up, and I'm going to set it equal to that total. So X plus 21,000 plus X plus 14,000 plus X equals 140,000. Okay, let's look for like terms. I've got 3 X's here. So 3X, I can combine the 21,000 and the 14,000. That becomes 35,000, and then I'm setting that equal to 140,000. What do I do now?
Minus 5,000.
Mm-hmm. So I have 3X equals, this would become 10,000 or 105,000. And then what do we do? Okay, so my X comes out to be 35,000. All right, so now I should be able to figure out the median starting salaries for everybody. So the median starting salary for education is just at 35,000. Because that's what we said was just X. For economics, we would have to take 35,000 plus 14,000. What do we get there? What's 35 plus 14? 49. And then computer science, you would take 35,000 plus 21,000 and you'd get what? 56,000. You guys just don't want to talk to me today? It's rude. All right, let's turn our page over. Okay, next one. You are choosing between 2 texting plans. Plan A has a monthly fee of $15 with a charge of 0.08 cents per text. And Plan B has a monthly fee of $3 with a charge of 12 cents per text. For how many text messages will the costs for the 2 plans be the same? All right, so we're going to have to set up 2 separate equations here for the 2 separate plans that we're comparing. But the goal is for me to figure out how many text messages would need to be sent so that it doesn't matter which plan I choose, that they would be equivalent to each other. Think of this also as like, because I think like paying for text messages is probably not something that you guys have ever had to do in your lifetime. When I was a kid, when I was your guys' age, we were paying per text message, okay? That was a long time ago. Now you just like pay for your phone plan and then you guys are messaging on all kinds of things. But on here, what I need to do is set up 2 plans. I want you to think about it like this. If you guys have like a membership somewhere, like a membership to like a gym or like if your family has ever gotten a membership to like, what is the matter?
Nothing. Jamie just laughed uncontrollably and it's making me laugh. No.
If you guys have like a membership somewhere, like I said, to a gym, or like if your family's ever gotten a membership to like an amusement park or something like that, like Arnold's Park, or maybe you've like gone to like a water park or something like that, You can pay like daily admission, or you can pay for like a membership fee just to like get in, and you could go like every day if you wanted to. So in that case, like I would think about like in my life, like I have young kids and we'll go to like the launch pad in Sioux City every once in a while, that children's museum. And we're at the point where with 3 kids and paying for 2 adults, it makes more sense for us to just get a yearly membership because we're going, a couple times a year versus like if I were to go and pay individually for every single person each time we went. So in that situation, like eventually when some of my kids get older and they don't want to go anymore, I maybe won't need a membership anymore. So it's kind of thinking about like that situation here. Is it worth it to just pay for it individually, or is it worth to pay for like the plan or the membership? Now we have 2 plans they're comparing, A and B. A says that it's $15 flat per month and that it's 8 cents per text. Think about the equation y equals mx plus b. Remember that m represents your slope and b represents your y-intercept. If I'm paying a flat fee per month, that would be like your y-intercept. Because no matter how many text messages you send, you have to pay this fee every single month. So for plan A, I have to pay $15 no matter how many messages I send. So 15 is going to be my y-intercept. That 8 cents per text message, that's my slope. So I'm going to write 0.08 x and then plus 15. How would I write that for plan B? Yep, 0.12x plus $3. What I'm trying to figure out here is when do these plans equal each other? When does plan A equal plan B? So I'm going to set these 2 equations equal. So 0.08x plus 15, we're going to set that equal to 0.12x plus 3. Okay, I like to keep my x positive if I can, so I'm going to subtract the 0.08x. I'm going to drop down the 15. 0.12 minus 0.08 would be 0.04. X plus 3. What would you guys do next?
Minus 3.
So I have 12 equals 0.04x. Then you got to divide by 0.04. What's that going to come out to be? Well, you have a calculator right in front of you. What'd you get?
300.
So this would mean at 300 text messages, the plans would be the same, or the plans cost the same. Once you pass 300, or if you're below 300, then they start to change. One plan will be cheaper than the other, and then eventually when it goes over 300, they'll flip. The other plan then will become cheaper. All right. Next one here on this page. Says after a 30% price reduction, you purchase a new computer for $840. What was the computer's price before the reduction? So I want you to think about this. You had an original amount that we don't know. So we're going to call that X. I don't know what the original cost was of this computer, but I know that my sale cost was $840. And I know that my discount was this 30%. Okay, if you had to find the discount of something, how do you do that? Like, let's just say something costs $1,000 and it was 30% off. How would you figure out how much you have to pay? What would you do with those numbers? Nobody knows? Don't you guys shop? Do you guys like buy anything ever? Don't you guys ever go somewhere and you're like, oh, they have a sale, it's 50% off. How do you figure out how much it is? No, you just pay for it. What if you have to leave a tip? You guys better leave tips at a restaurant. How do you guys do that? How do you figure out how much you're going to leave for a tip? A calculator, but what are you typing in on your calculator? The decimal. So you're never gonna, if you were gonna leave like a 30% tip, would you take the amount times 30? Heavens no. You're a really good tipper. You have to write the percentage as a decimal. And then you take that like times your cost. And then if it's being added on like tax or a tip, you would add it. If it's discount, you subtract it away. So in this case, if I know I have 30% off, I would have taken 0.3 times my original amount, X. That would tell me how much I don't have to pay. And that would be taken away from the cost. Because I would take whatever my original amount was, I would subtract my discount, and that would give me my sale price. We don't know what the original amount was. We just know that it cost something. So we're going to call that X. We know that the discount was found by taking 30% of that cost, so 30% of X, and that equaled $840. If we combine these terms on the left, it's like 1x minus 0.3x. That's 0.7. Which should make sense. If you're not paying for 30% of the cost, you are responsible for paying 70% of the cost then, because you have to make up the difference to 100%. So then I'm going to divide by 0.7. What's 840 divided by 0.7? What'd you get? 1,200. So this computer would have cost $1,200 originally. All right, next one. The length of a rectangular basketball court is 44 feet more than the width. If the perimeter of the basketball court is 288 feet, what are its dimensions? Do you guys know how to find perimeter? You add up all the sides. There are a couple formulas we could use for like a rectangular shape. You could take 2 times the length plus 2 times the width. Or you could do 2 times the length plus the width. You could write it with the 2 on the outside if you wanted to. So let's figure out what we know here. I've got 3 letters that I want to try to put stuff in for. Do I know what the perimeter is? Do they give me that in my problem at all? 288 is my perimeter. Do I know length or width or anything about them? Okay, so it says the length is 44 feet more than the width, right? So do I know anything about the width? So I'm just going to keep W as W, but I know that the length is whatever that number is plus 44 because it's 44 more. Okay, so now I'm going to plug in what I know. So in for P, I'm going to put 288. In for the length, I'm going to put W plus 44. And then plus 2W is going to stay as is because I don't know what the width is. I just know that it's W. Now I'm going to solve this. I'm going to distribute over here. So that becomes 2W plus 88. So I've got 288 equals 2 or 4W now plus 88. Go ahead and solve for W. What do you get for W? 50. Okay, so they want to know what the dimensions are. So 50 would be one of those dimensions. So it's 50 feet by, how do I find the other one? Add 44. So that would be 94 feet. So these would be my dimensions. If I wanted to check it, I could take 50 and 94. I could plug it in up here to my perimeter formula. I could take 2 times 50 plus 2 times 94, and I should be at 288. That would just be a quick way I could check it, make sure I solved it correctly. All right, these last couple of examples that we have, they are not like what we've been doing. They are giving us formulas, but they want us to rearrange the formula for a different letter. So you're not going to get an answer like 50 feet or 94 feet or x equals 1200. You're going to be giving me a new formula that still has letters involved. We're not plugging in numbers for these letters. We're just rearranging the formula for a different letter. So this first one wants me to have this formula, and we just used this one. This is a perimeter formula. P equals 2L plus 2W. They want me to solve this for W. So first of all, if I look at these, do you guys think it would be okay if I factor out a 2? Could I do that? I mean, we could. I don't know if we need to necessarily for this first one. Sometimes factoring might help if you're going to be moving that entire quantity over. But it might be easiest actually if we just try to separate these two terms. What's in between the 2L and the 2W right now? A plus sign. So I want to move the 2L over to the other side. So I'm going to do that by subtracting 2L. So I'm going to write minus 2L on either side. So this now is going to say P minus 2L, and that's going to be equal to 2W. How do I get the W all by itself? Divide by 2. I'm going to divide that on both sides. Okay. On the left side, I'm going to tell you, you can't do anything with it. But why? Because I had someone ask me earlier, why can't I cancel out those 2's? The other 2 doesn't have an L, that's true. But why can't we just cross off those 2's? Anyone know why? Two doesn't go into P. What number's in front of the P? A 1. If you're going to take the 2 out from like the bottom, you have to be able to take it out of every single term in the problem. And you can't do that with the P. So that's why you can't take that 2 out. You have to leave it right here. All right. Now this next one, I want to solve this equation P equals C plus MC. I want to solve it for the C value. In this case, because they both have C in them, and that's what I want to solve for, it's going to be easier if I just have a singular C in this problem instead of multiple. So I am going to factor out the C this time. If I factor out a C from this quantity on the right, I would be left with a 1 plus M. Now I only have one C in my problem, which makes this a little bit more manageable because I just want to get that letter by itself. How do I get rid of that quantity though, 1 plus M? What operation's happening with the C and the 1 plus M? we'd have to divide because right now the c and the 1 plus m are being multiplied together. So I'm going to divide both sides by 1 plus m. So then over here, these are gone. I finally get that c by itself. And over here on the left, I have p over 1 plus m. Can we do anything else with that? I don't think so. Questions on those two where you're rearranging formulas? They're a little different. You're not going to get a number for an answer on those. You're just going to get another new formula that looks different. All right.